Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 सीबीसीएस ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें ग्रीन्स थ्योरम एंड इट्स एप्लीकेशंस विषय रे पढिबा सो फॉर दिस लेट अस कंसीडर R to be a closed region in the xy plane which is bounded by a simple closed curve C. Further, let mxy and nxy be continuous functions of x and y with continuous derivatives in the region R. Then, as per Green's theorem in the plane, the line integral taken over the closed curve C of m dx plus n dy should be equal to the surface integral taken over the region, that is of del n by del x minus del m by del y of dx dy. Okay, and here the closed curve C is traversed in positive direction. Okay, that means counterclockwise, that is anti-clockwise manner. Okay, now let us prove this. For this, let us consider a simple closed curve C which is divided into two curves C1 and C2. Okay, so this is the curve C and we have divided into C1 and C2, right? Here C1 means ABE, this part, and C2 means EDA, okay, this part, right? Now let the equation of the curves ABE and EDA be respectively given by y equal to f1x and y equal to f2x. Now if R is the region which is bounded by the curve C, then we have the surface integral of del m by del y of dx dy. Okay, so याको आमे एबे लिमिट पुट करि परिबा x limit हे जबो एठी x equal to small a to small b. Okay, here are the limits small a and small b, right? Similarly y limit हे जबो from f1x to f2x, right? So याको एबे आमे जदी आकु इंटीग्रेट करी करी जिबा ताले finally we will get the solution like this. Okay, so minus the line integral taken over the closed curve and it is of mxy of dx. Okay, so here we have used the formula, that is integration, the line integration over m dx should be equal to minus double integration, that is the surface integration over del m by del y dx dy. Okay, this we have used. Okay, now let the equation of the curves BAD and BED. Okay, so we have taken these curves. Okay, BAD means this one and BED means this one. Okay, so suppose the equations of these two curves are given by x equal to capital F1y and x equal to capital F2y. Then similarly we can calculate the surface integration over del n by del x of dx dy. Okay, and we will take the limits of y here to be from e to g. Okay, as you can see in the figure, here the y limits e and g, and the x limits will be obviously capital F1x and capital F2x. Okay, so these are taken and calculated again in the similar way and we will arrive at this result. Okay, the line integral taken over the closed curve of n dx, this should be equal to the surface integral taken over the region of its partial derivative, that is del n by del x dx dy. Okay, so let us now add equation 1 and 2 so that we will arrive at the result, that is the line integral taken over the closed curve C of m dx plus n dy should be equal to the surface integral taken over the region R of del n by del x minus del m by del y of dx dy, which is your Green's theorem in a plane. Okay, now in vector notation, the Green's theorem will be like this. Suppose we take a vector f, and this is equal to m I cap plus n j cap, and suppose r is equal to xi plus yj, that is the radius vector in the xy plane. Then dr will be this much, dxi plus dyj. Then actually we have a printing mistake here. Instead of equal to symbol, this should be dot. Okay, so this should be f dot dr, whose value will be m dx plus n dy. Further, its curl, that is del cross f, will be del n by del x minus del m by del y k cap. Then del cross f dot k cap will come out to be del n by del x minus del m by del y. Now using dr to be equal to the product of dx and dy, we can rewrite the Green's theorem in the plane like this. By replacing the values, we get the line integral taken over the closed curve C of f dot dr to be equal to the surface integral taken over the region R of del cross f dot k cap dr. Okay, so this is the Green's theorem in vector form. Now let us move further. Let us see the application of Green's theorem. So first application is the area of a plane region. Okay, so from Green's theorem we already have the format like this. Now let us put capital M to be equal to minus y, capital N equal to x. Then accordingly the partial derivatives will come out to be minus 1 and 1. So replacing this value in RHS of equation 1, we have 2 times of surface integral taken over the region R of dx dy, which is nothing but the area. Okay, here capital A is the area, not tree. There is again a printing mistake, right? So 2 times of area. Then we have the area like this. Okay, this integration, surface integration, which is coming out to be 2a, that means the area A will be equal to half of the line integral taken over x dy minus y dx after replacing the values of m and n. Okay, so this is the expression for the area in terms of integral over the boundary. Now the second one application is the area in terms of polar coordinates. Okay, so for this we use the transformation equation x equal to r cos theta, y equal to r sin theta. Accordingly dx will be this much and dy will be this much. Okay, now after calculating the values, we have the area A to be equal to that we have got in the first case. Okay, this we have got. So here let us replace the values of x, y, dx and dy and calculate further. Then its value finally will come out to be half of the line integral taken over the closed curve C of r square d theta. Okay, now let us solve some of the problems related to your Green's theorem. So in example 1, it has asked to evaluate the line integral, this one, where C is the ellipse which is given by this equation. So you can see from this integration, actually it is in the format m dx plus n dy. Okay, if you multiply this exponential with this one and this one, then it will come out in the format of your Green's function in the plane, right? So let us multiply. Okay, so we can have m equal to e to the power x sin y and n equal to e to the power x cos y. Accordingly we can find the partial derivatives. Now according to Green's theorem, we can replace this line integral with its surface integral. Okay, so upon replacing by its surface integral, finally its value will come out to be 0. Okay, now the second example, evaluate again the line integral it has given, and here C is the boundary of the region which is enclosed by y square equal to x and y equal to x. So again from this integration we have m equal to x square y, n equal to y square. Accordingly, we can have the partial derivatives. Now replacing the line integral with its corresponding surface integral, then putting the values. Okay, after integration we have now put the values, that is 0 to 1 and square root of x to x, right? So these values we have got from the equation that it has given. Okay, here y square equal to x, that means y should be equal to square root of x, right? And another thing it has given y equal to x, that is why we have put the limits here for y to be initially square root of x and finally x. Okay, and the x limit that we have got from this curve. Okay, this is the curve for y equal to x and this is the curve for y square equal to x. So the intersection points are at x equal to 0 and x equal to 1. That is why the limit of x are taken here to be from 0 to 1. Okay, right? Now you can see after integration and putting the values of the limit, the final value will come out to be minus 1 by 28, right? Now let us go further. Example number 3, find the area of the ellipse. It has given the equation x square by y square plus y square by b square to be equal to 1. So for this, let us transform the coordinates into the polar coordinates, right? So x equal to a cos theta, y equal to b sin theta, let us say. Then dx and dy will be like this. Now using the Green's theorem of area of ellipse, we have actually the area should come out to be half of its line integral over x dy minus y dx. Now putting the values and calculating further using the limit of theta, that is 0 to 2 pi, we can have pi times of AB. Okay, so this should be the final value of the area of the ellipse. Okay, then come to the example number 4. Here again it has given a line integral, okay, which is in the format of your Green's theorem in the plane, and C is the square which is formed by the lines x equal to plus or minus 1 and y equal to plus or minus 1. So accordingly we can draw this square. This is x equal to 1, this is y equal to 1, this is x equal to minus 1, this is y equal to minus 1. Okay, and here from this line integral we can have m equal to x square plus xy and n equal to x square plus y square. Accordingly we can find the partial derivatives. Now let us apply the Green's theorem and replace the line integral with the corresponding surface integral. Now thereafter you replace the values accordingly. Now ଏଠି ଫିଗରରୁ ଜଣା ପଡୁଛି ଯେ x ଆଉ y ଦୁଇଟା ଯାକର limit ହେଇଯିବ from -1 to +1. Okay, so after using these limits and calculating further, the final result will come out to be 0. Okay, then come to example number 5. ଏଠି ଗୋଟେ vector ଦେଲା f equal to -y cube I plus x cube j. ଆଉ evaluate କରିବାକୁ କହୁଛି the line integral of f dot dr, and here c is the circular path which is given by the equation x square plus y square equal to a square. So ଏଠି ଦେଖ x ଆଉ y ର କିଛି ବି limit ଦେଇନି, ତେଣୁ ଏଇ ଯୋଉ equation ଦେଲା ଏଇଥିରୁ ଆମେ ପାଇପାରିବା y square to be equal to a square minus x square. That means y should be equal to square root of a square minus x square. Further x रो लिमिट जानिबा पई आमे एठी कोन करिबा ना y स्क्वायर को और y को एठी 0 पुट कर दबा. दैट मीन्स x स्क्वायर आसी गला यार वैल्यू इक्वल टू a स्क्वायर और x रो वैल्यू ही गला स्क्वायर रूट ऑफ a. सो एठी स्क्वायर रूट जो आछि एठी प्लस और माइनस दुईटा वैल्यू पाइबा हमें. अकॉर्डिंगली x पाई मध्ये प्लस और माइनस दुईटा वैल्यू हमें पाइला. ओके, सो दीज आर द लिमिट्स. सो लेट अस कैलकुलेट द लाइन इंटीग्रल. हियर f रो वैल्यू एठी हमें पुट कला dr तो वैल्यू हमें जानि छु dxi plus dyj. ताले याको हमें ई फॉर्मेट रे आनी परिबा. ओके, m dx plus n dy. एठी m रो वैल्यू हबो minus y cube, n रो वैल्यू हे गला x cube. ओके, अकॉर्डिंगली पार्शियल डेरिवेटिव हमें इजीली बाहर करि परिबा. सो let us apply the Green's theorem. Okay, now after application, let us use the limits of x and y. Okay, jota mu कहली. Okay, now after using the limits and calculating further, ame एतिकी जगार पहुँचला. Okay, so देखो 12a square, then integration from 0 to a, then square root of a square minus x square dx. So एठी आमे कौन करिबा, ए जो x को रिप्लेस कर दबा with a sin theta, ताले dx हे जबो a cos theta d theta. Okay, so thereby we can calculate further. ताले final result आसीगला, check करिबो 3 pi a to the power 4. Right, then come to example number 6. So एठी कहूची verify करिबाकू Green's theorem by evaluating the line integral over the closed curve C. Okay, this is the line integral where C is actually the square with vertices at points 0 0, 2 0, 2 2 and 0 2. Okay, so आमे जानिछु Green's theorem रो format हला या. So এই लाइन इंटीग्रल को लक्ष्य कले जଣା पड़छि m equal to x cube minus xy cube हबो आउ n equal to y square minus 2xy हबो. Accordingly partial derivatives आमे बाहर कर देला. Now एठी जो ई vertices देला स्क्वायर रो इथरु आमे x और y रो वेरिएशन बा लिमिट्स जानि परछु एटा 0 आउ 2 भितर ही वेरी करछि. राइट, सो इक्वेशन 1 को एबे हमें रिप्लेस करि परिबा विथ दैट ऑफ द सरफेस इंटीग्रेशन and we can put the limits of x and y to be from 0 to 2. Okay, and the final result will come out to be equal to 8. Okay, now let us move further, the verification of the theorem. Okay, so এই जो theorem को हमें verify करिवार अछि. Okay, example टा एबे भी सरीनी. So देखो एठी ये कहूची the region of integration एठी दोची गुटे square जेहेतु with vertices 0 0, 2 0, 2 2 and 0 2. Accordingly हमें square को draw कला a b c d with the respective vertices. ताले एठी हमारो line integral थिला या. So याको हमें चारि भाग रे suppose भाग कर देला I1, I2, I3 and I4. Okay, where I1 is the integration of the given function along AB for which y equal to 0 and dy is also equal to 0, but here x is varying from 0 to 2. Right, ताले एठी हमें I1 को बाहर करि परिबा. Okay, over the surface that is AB. Okay, ताले I1 रो वैल्यू देखो एठी बाहर कराइछि equal to 4 आसिला. Similarly I2, there is the integration along BC for which x equal to 2, dx equal to 0 and y varies from 0 to 2. ताकू एबे हमें इजीली बाहर करि परिबा -16/3 आसीबो. Then I3 एबे बाहर करिबा integration taken along CD for which y will be equal to 2 and dy equal to 0. ताले I3 रो वैल्यू एबे अकॉर्डिंगली हमें बाहर करिबा. एठी देखो गुटे प्रिंटिंग मिस्टेक अछि. ए जो इंटीग्रेशन रो लिमिट एटा 0 to 2 हबनी, rather it should be from 2 to 0. Okay, because CD जेतेबेले हमें फिगर को देखो एठी जेतेबेले C रो D को हमें जाउछु ताले x रो वैल्यू एठी C रे 2 अछि, D रे 0 अछि. सो इनिशियल लिमिट 2 हबो, फाइनल लिमिट 0 हबो. ओके, सो एटा मु एडिट कर देबी. सो अकॉर्डिंगली यार वैल्यू देखिबो चेक करिवो आसीबा कथा +12. Then I4 integration taken along DA for which x equal to 0, dx equal to 0 and y will vary from 2 to 0. Right, so सेही बलिया याकू भी आमे बाहर करि परिबा. यार वैल्यू टा फाइनली आसीबो -8/3. सो एबे हमरो टास्क हला टोटल इंटीग्रेशन बाहर करिबा by adding I1, I2, I3 and I4. Okay, so यार वैल्यू देखो आसीगला 8, which has verified the Green's theorem. Okay, thank you.